going to be graphing polynomials. This is 1-3. Okay. With that being said, I don't want to get it exact graphed. I want to know what it has a generalized look. Okay. With that being said, the things that I want you to know is end behavior. End behavior dictates what a graph's going to look like quite a bit, doesn't it? Okay. Also with end behavior, we know that with an leading coefficient dictates end behavior just as much. Okay, so we need to know leading coefficient, we need to know end behavior. How do we find end behavior? The degree and the leading coefficient, right? That dictates end behavior of our polynomial. You guys agree with me so far? Okay. The other thing, the most accurate you're going to be today is finding the zeros. You need to know where the zeros are. How do we find zeros? What are ways that we've already learned how to find zeros? Go ahead, Dan. Completing the square, which I never want to do ever again. What do you got, Curly? You could, though. Good. Quadratic formula or factoring. Those three ways, right? Those are the ways that we know how to go ahead and find zeros currently, right? What's the highest thing that we could really solve for? Can I do number 2 if our bell quiz, if it said x squared minus 5x squared plus 4? Could I keep going with that? I could, because it's in terms of a binomial and I can go through that. Might be just a little bit different, but I can factor, right? I can do quadratic formula, or I can go ahead and just solve maybe like if it's x squared plus 4, I can go ahead and solve that one, right? Plus or minus 3y. But the new thing that we're going to learn today, you also need to learn new is end behavior, zeros, and the multiplicities with their zeros. So multiplicity is the new word that we're going to learn today, and I'm going to explain that first. Okay? And I'm going to explain it using other graphs that you already are familiar with. Okay? So, really quickly, how would I graph f equals x cubed? We've seen that before. I've showed you at least once, right? What does that look like? Kind of like comes down very steep and then goes up really steep, doesn't it? That's a basic x cubed graph. Okay, where does it cross the x-axis? At 0, 0, or at x equals 0, correct? Now, where do I know that x equals 0 just from this? Just from the equation. How can I tell x equals 0? Well, I'm looking for where the zeros are, or where it hits the y-axis. And anytime the x-axis, anytime I hit the x-axis is when y is 0. Right? What value makes that guy 0? Now, I believe I mentioned in the past days, I don't remember what day I mentioned it, but did I mention the fundamental theorem of algebra? Have you guys heard that yet? The fundamental theorem of algebra states, whatever your degree is, what is our degree of that polynomial? 3, right? Our degree is 3, correct? The fundamental theorem of algebra says that guess how many zeros there will be? 3. But ladies and gentlemen, I only have 1 0. It's only 0. How is there 3 zeros, but only one of them is or it's just 0? I could have imaginaries, but in this case, it doesn't have imaginary. And I'll show you right here. Was that maybe? Go ahead. It is the multiplicity of 3. Did I bring up multiplicities in the past? I did a little bit. Okay. So what this means is, notice, what's x cubed? Another way to write x cubed. That'll be that last one. So, ladies and gentlemen, what's the 0 of that guy? 0. What's the 0 of that guy? 0. What's the 0 of that guy? So is there 3 zeros? There are. It just happens to be the same 0. Does that make sense? And when you have more than 1 0 at the same location, that's when we call it a multiplicity. So 0 has a multiplicity of 3. Because we are using 0 3 times as a 0. Does that make sense, what I'm trying to go for? Okay? Now I want you guys to notice something. As we went through, we crossed and we kept going up. We went from a positive to a negative, didn't we? That's important. Look right here. You might want to visualize this and this in just a second. Talk about that. Okay. Onward. X squared. What's it? 0. 0. Okay? So we're here. What does it look like? Parabola. Woo! Right? Okay? There's something different this time. First off, what's my 0? 0. What's my degree? 2. What's my multiplicity on that 0? 2. Right? So therefore, though, I want you to notice the difference. What happens here? And it'll always be this case. Okay? Let me just show you something else. If I said x minus 1 squared, what's the 0 on that one? 1. Because remember, it's just x squared doing what? Shifting leftward, right? Does that make sense to everybody? Okay? What's my 0? 1, right? 1 is the value that makes this guy 0. Do you guys agree with me? Okay, what's its multiplicity? 2. Okay, what's similar here but different? Well, 1, they're different zeros, but what's similar here? They have the same shape, right? Not necessarily the same parabola. Same shape, that's true. Say what, Brielle? I'm sorry. And behavior is the same. That's great because of the degree, right? This would come out if I distribute him through x minus 1, I'd get x squared, right? Good. They touch the axis. I really like that. We call it bouncing. They bounce. Notice, I went positive. Went right back to positive. What if I had this graph? What does that do? We went from this to what? Where's our 0 at? Still 0? Sorry. Oh, that's horrible. Don't even happen. Oh. Oh. That was the worst. Oh, that looks pretty, doesn't it? There we go. So once again, what happened here? It bounced. Why is it bouncing? Because it's an even multiplicity. Anytime. Look at x to the 4th. What's he going to do? Once again, he's a little flatter, but he bounces, doesn't he? What does x to the 5th look like? He'll still have 5 zeros at that 0, but he's going to cross, right? He crossed. So that's the key thing I want you guys to know about today. The biggest thing today. Even multiplicities. Is a count. Odd multiplicity. Yeah, we say cross. Yes, James. Okay, so looking here, this one's slightly different. No, not necessarily. Give me 1 second. I think I'll answer your question. Just give me a little bit more, okay? And I think I'm going to answer it. Now, coming back here, let's do just a very basic one. Really quickly, what would that be as factor form? Does everybody agree with x and x and x and x? Two factors of 2 that you 3 is -1 and 2. Okay, thank you, Brady. So James, hopefully I think this is going to answer your question. Now I understand not every single one's even. I understand that. That's kind of what you were going over here, I believe, a little bit. But bear with me just for a second. Okay. So what's my zeros? 1 and 2. Now, for those that have graphed, I could go ahead and find my vertex. I'm not caring right now, but basically it looks like that. Okay. Notice just because it's x squared doesn't mean that it will have even multiplicities at the zero. Did I have even multiplicities? What's the power here? 1. His multiplicity is odd, so that's why I cross here. Does that make sense? What's his power? And he crossed. Does that make sense? Does that answer your question? So looking at the zeros. So when I'm in factor form, okay, the key thing is looking at factor form. Is that in factor form on number 2 of the bell quiz? X to the 4th minus x squared minus 4. Is it in factor form? No, it's in standard form. So therefore, because it's not factor form, I can't even talk about multiplicities yet whatsoever. Now, were you talking because it's an even function? No. That is a good thing to help it make it even function. But if all of them were, yes, that's going to happen. Is that what your question was? I apologize. I'm trying to get there, but sometimes you just try to figure out exactly that. No. What are the zeros that make this work? So if I set him equal to 0, what value makes him 0? What value makes him 0? Does that answer your question?
So why is that like
okay, that's the key question. Last time when we had an x squared, what did we have? We only had 1 0, didn't we? Okay. With that 1 0, it had an even multiplicity. Looking here, how many zeros do we have this time? 2. And we should have 2, right? Why should we have 2? Because it's an x squared. An x squared tells us we will have 2 of them. Huh? Do we have 2 zeros? Are they the same? No, but there's still 2 zeros. Now, when it was x squared, we had 2 zeros, but it was the same number. Hence, its multiplicity was even. And at that point, it bounced. So looking here, Jaden, what's my multiplicity? 1 and 1. This has 1 0 at 1 with a multiplicity of 1. This has a multiplicity of 1 at 2. So looking at those zeros, I should be crossing. Because even multiplicities cross, odd multiplicities cross, even multiplicities bounce. Have it. Parabola. Okay. Doesn't touch anything, such as x squared plus 1. Gotcha. Something even over here. Okay. Okay. Great question. So let's go off assuming this one. I'll just give you the idea. Okay. So I have f of x equals x squared plus 1, which we already graphed, which knows that it has no zeros. Does it have no zeros? It has zeros. It doesn't have real zeros. But does it have zeros? Yep, let me just show you. Okay, so we plug it in. That's a great question, by the way. I'll go ahead and solve it. So when I take the square root, I get x equals plus or minus root -1, which is plus or minus I. How many zeros is that? 2. How many zeros do I need to have for an x squared? 2. So, does it still have zeros? Yes. But are they graphed on our real number line? No. Could you graph them in the imaginary plane? Yes. Okay. Did that answer your question? And even this guy, you just have imaginary solutions as well. So even though I didn't do this one, his solutions is good. Okay.
When did you ever have an instance where it's accidentally zero, because it was just one, right?
Well, really to be the case, I mean, that's just constant, right? If you ever have an exponent of 0, that's just a constant. So, oh, okay, maybe I see what you're saying. All right, so if I had like the x squared, that's x times x, right? So what is my 0 for this case? 0. What's the value? I'm asking, what is the 0? What value makes him 0? Right? 0. And he is 0. Oh, it's the same thing. Am I going to plot that twice? No, I'm still going to just plot that one time. But notice how many of my zeros are 0? 2. Okay. Let me give you one more time. Let me just see if I can get you guys a little bit by doing another problem. Hopefully just to clarify some more things out. So, that's a 2x minus 1. And we're going to do the whole thing, the whole shebang. This is pretty much the whole freaking day right here. Okay? So, first off, and you want to graph that. Graph means accurate, sketch does not. Correct? Everybody with me on that? The only thing I want you to use on this sketch really though is your end behavior. How do we know end behavior again? Where do we find that? Through our degree and our leading coefficient. You guys agree with that? How many of you guys really want to take the time and freaking boil that sucker out? Because I got to go x to the minus 4 times x minus 4 times x minus 4 times x minus 4 to get that thing. Then I times that to 2x minus 1. Then I get that thing. And then I times it by x cubed. So I can still do this though without having to put it in as a polynomial. Okay? Does that make sense to everybody? First off, what's my degree? It's not 3. What'd you say, Brielle? It is 6. And here's the reason. How many zeros do I have at 0? I have 3 zeros there, right? So I'm already x cubed right there, huh? How many zeros are here at 4? So now I'm at 5 zeros. So I at least have to be x to the 5th, right? And then I add another one at a half. So what is this raised to? X to the 6th. This is a 6th degree. Does everybody understand how I do so? All I have to do if it's in factored form, okay, if it's in linear factor form, count your multiplicity. Okay? Does everybody understand how I have that? Because remember, if I have 6 zeros, that means I have to be x to the 6th because that's the fundamental theorem of algebra. Right? The number of zeros will equal your degree. Okay? So it's a 6th degree. So 6th degree means we're here, huh? We're here. We don't know yet. But one or the other. You guys agree? What are we? Are we up? Or are we down? We're up. Let's check. Here's the reason why. What would this come out to be? X squared, wouldn't it? I don't care about the rest, but x squared, right? What's x cubed times x squared? X to the 5th times by 2x. 2x to the 6th. That's my leading coefficient is 2. So therefore it will be going up. Okay? Everybody with me here? We will be going up because our leading coefficient is that. So just be aware, guys, I will be taking your calculator away from you on this stuff. And you just can't look. But the goal is to look at what you have and what you can do with it, right? Are you understanding the concepts of what's happening and how to get to where we're at, right? So I might take it away, because if you do, then you just look at it, you're like, oh, I can graph it, right? There's parts. There'll be some and without. So it's not necessarily the whole test is going to be calculated, and some of them are. Answer your question? Okay, what's our zero? Let's go to the next things. We found our leading coefficient. We found our degree, which helps us with our end behavior, right? The next part is our zeros and their multiplicities. Trek, what's the zero here? That is our multiplicity is 3. 0. Trek, I'm going to get you again. What's the 0 here, Trek? What's the value mixing 0? 4. What's his multiplicity, though? 2, right? What's his guy's 0? Right, Jake? Half? Good, because I'd add 1 divided by 2, right? I'd add. You guys want me to show the work, or can we see a half? Add the 1 to the other side. Oops, sorry, that's a minus. See how I got a half? Or how James got a half. Okay? That just looks like 2. Okay, we only have 3 physical zeros, correct? But we have 6 total zeros. Get the difference? We have 6 physical zeros we're going to put on our number line, right? Let's say 6. 3 physical zeros that we're going to put on our number line, but there's a total of 6 in general. Okay, so 0 is a 0. 4 is a 0, and a half is a 0. Does everybody understand where I put those values and why I put those values on the number line? Can it cross anywhere else? Or bounce anywhere else? No. Or there'd be other zeros, wouldn't there? Does that make sense? Okay. All right. Once again, here's where we're going to go. We had this end behavior, didn't we? So notice I'm going to start here. I should end up here. Let's see if we do. Right? So we're going to start here. Coming down, I know the first time I'm going to get even close is right there at x squared, huh? Excuse me, at the 0. Is it odd or even multiplicity? Odd. Odd, right? So do I cross or do I bounce? It's an odd multiplicity, I cross. Now I don't care if you go all the way down, but I know sooner or later I'm going to come up right there. Now, could it be just barely under it? Once you sketch, correct? Yeah. Okay, I'm at a half. What am I doing? What's my multiplicity? 1, right? So therefore it's odd, so therefore I crossed. Okay, I don't care how high I come, but for sure I know I end back up here, don't I? Let me just finish, I'll come back to here. Okay, 4. What's his multiplicity? 2, so therefore it's even rod. Even, so therefore we're going to. Did I end up with the end behavior I was requiring? Zero is not even. 0 is the number. Look at the multiplicity. The multiplicity is odd. That is what made it go through. Not the number itself, but the multiplicity on that 0 made it go through. Really, does that make sense? Jules, you okay? James, we're good now? Now, if you guys graph this, what would it look like this? Would it have you bouncing and crossing at the same points? Sure. Once again, this is a sketch. Okay? I can always tell when I tell them not to use their calculator and they use their calculator because they sketch it just like the graph does on the calculator. No mind. If you're sketching it, you would never graph that. You know what I mean? So I can kind of tell when I'm asking you to be honest with me and you're not. So remember, how do I find it? Degree, leading coefficient, using the zeros, finding the multiplicity of those zeros, right? With that being said, I start with my end behavior. I go to my first zero, and then I use my multiplicities, and I cross or bounce depending upon what it is. And I should end up with my end behavior. If I don't, what does that tell me? If I have x to the 6th, and all of a sudden I made myself an x to the 5th graph, I messed the heck up somewhere. Either A, I started with the wrong end behavior, or 2, I bounced across when I should have, one or the other. Does that make sense? How we can kind of check that? Right. Can I go on? Or do you guys want to hold this for a minute so you can copy it down? Now, on your homework, it talks about, oh, here's some zeros. Tell me your polynomial. How do you do so? Doesn't matter. What they're telling us 5 zeros. How would I find that polynomial? You go, like, say it's 1, 2, 3, 4, 5 are my zeros. Go x minus 1, x minus 2, x minus 3, x minus 4, x minus 5. And then I got to do the painstaking process of distributing that. So hopefully, x cubed is the highest it goes, hopefully. See what I'm saying by that, though? Not too hard. We've already talked about that. Put them in linear factors, distribute them through. If I'm really not going over that much. Okay. All right. We get a nasty one. You guys excited to get all nasty? I get excited. Oops. That'll work. Okay. How many physical zeros are we having? Physical zeros. Meaning things that we're going to put on the number line. 3, right? We're going to have physically 3 zeros. Physically. Meaning, I'm going to plot 3 things, correct? What are those 3 things? 0. 3/4. And 1/3 is correct because James subtracted 1 and divided by -3. -1 divided by -3 is 1/3. All right, so now we have our physical zeros up there. Does everybody understand where I found those zeros? Set each of those things equal to 0, right? Yes, my man Daniel Layton.
So the 4x minus 3 would be like negative 3/4. So that would be 0.
That would be 0.
Okay.
Because I can set 3x minus 4 equal to 0, add the 3, divide by 4. Are you in 4-H? Do you have a 4-H? Used to do? I used to do a lot of things.
How does the negative 3x turn and plus 1 turn into a 0?
Okay, can help you there. So once again, we're setting where all of these guys equal to 0. Basically, I just need to know when this is 0 to the 4th is still 0, right? Your question? Okay, just set him equal to 0. I set him equal to 0. I set him equal to 0. Right? Good? Yes. Exciting. Okay. So, we need to know what else. We need to know our degree, huh? Now then. Our degree is 9. How did we get 9, Daniel? Well, how many zeros come from him? 2. plus 4 more. 9. We're x to the 9th, so we're like, ba-dum. Like oh. I don't know that yet. That's just from our degree, huh? Hey, here we go. Now we need to find our leading coefficient. Am I going to hurry and times this whole crap out? Not only no, but a heck no. Okay. Don't want to do that. Do I get a little too loud? I'm sorry. I am too. This is my tiredness. Okay. So notice, guys, what would this be after I distributed him through? It would be positive, wouldn't it? Because 4 times 4 times 4 is a positive number. Positive. What does this come out to be? Negative times a negative times a negative times a negative. So we have a positive x to the 4th, positive x cubed. I'm at x to the 7th. I take a positive x to the 7th and times it by negative 2x squared. I come out negative, don't I? So I was here because of my degree, but my leading coefficient says otherwise, and we go wrong. Okay. Oh man, you're gonna really make me do that. Okay, so that's 81 times 64 times negative 2, whatever that number is. 81 times 64 times negative what? No. 81 times 64 is a bigger number than that. There you go. Okay? But you get the idea behind that. I don't really need to find that number. I need to know, okay, this guy's a negative. When I'm done doing all this stuff, what's my leading coefficient come out to be? Positive. When I'm done doing all this stuff, what would it come out to be? Positive. And so then I times that negative in. Oh, the negative times the positive is negative. Oh, I take that negative and I times it by that positive. Oh. It'll come out to be negative. Is it Caitlin or is it Kaylin? It is Caitlin. Hi. Oh, no problem. Okay, what? Because he's negative 2x squared. He's done as a binomial as is. Nope, that's not the thing. Get rid of that. Undo, undo. Control C. Okay, so this is already done, foiled everything. Negative 2x squared. So he's negative as is. I'm not doing negative x, negative 2 squared. If it was looking like this, which I think you're kind of thinking, what would that come out to be? But is this and this the same? No. Is this the same? I'm squaring the x with the negative 2 out. No. Because when I do this, let me scroll down just a minute. I don't really care what it was or whatever, because I think I'm just explaining to you, right? Ready? Because that was within the parentheses, correct? Within the parentheses, so I did it 4 times. So really, if I wanted to find out this, I'm going to go negative this times this, which would be 9x squared plus crap, right? I don't care what it is. 9x squared times a negative 3x. Negative 27x cubed and crap. Because once again, I'm only caring about the coefficient, so that's why I'm not, you see where I'm going here. Negative 27x cubed times negative 3x. Positive 81x to the 4th. See where I'm going there? See how I did that? Good question. Good question. Okay, I want to hurry quickly. Daniel, do you have something?
Well, I mean, the 4x cubed. If the x is a negative number, couldn't
that would be negative? No, but okay, I see what you're saying there. Okay. But at the same time, we don't know what any of this is. Because if x was negative in general, okay, that's going to then notice, let's say negative 5. Okay, bear with me. What's 4 times negative 5? Negative 20, awesome. Whatever that is, cube it, that's negative. Okay, negative 5, that's negative times a negative, and then this will come out to be positive no matter what. But it's not a positive number that I'm saying. Okay? Because once again, this is the coefficient. The coefficient dictates what it's doing. Because once again, on an x cubed, because once again, it comes back to its parent function every time, right? Could have stuff after it. All that other crap after it. That's what makes the body of the graph, right? It doesn't affect the end behavior, though. Because the end behavior is going to look like this if it's x to the third or x to the ninth. Now, when I times that number, whatever that number is when I come out of plugging x's in, okay, it'll flip it by depending upon your coefficient. You get what I'm going at there?
Yeah.
The other part creates the body, hence why it does go up and go down and all this other stuff. Because certain levels take over during that part. I don't know if you guys get what I'm taking by taking over. What I mean by that is if I FOILed this out, maybe at a certain point, the linear term is bigger than everybody else, right? So he's leading during that time, okay? If I have x to the 8, all of a sudden he's taking over. That's why he skyrockets really quick and is positive. You get what I'm saying? There's certain values that it starts taking over the graph. But in the end, x to the 9th is the big boy, isn't it? He's going to take over when we get to the huge numbers. Okay? Does that make sense, Daniel?
Yeah.
Okay. All right, let's get to the graph. X to the 9th, but leading coefficient negative, so we're starting high, ending low, correct? Okay, here we go. Starting high, ending low. That's our goal. Let's see if our bounces and our crosses dictate that same thing, okay? Starting high. Coming to 0, which is this term. What is our multiplicity? 2. Because it is 2, not this number, just be aware. Okay? 2, are we bouncing or are we crossing? Bouncing. Okay, we're coming up. Woo, woo. I'm right back here. Now I'm at a third. This is the third one, isn't it? This is the thing that gave me the 0 of a third, correct? What's my multiplicity? 4, so therefore even, so therefore we are going to bounce. Coming here at 3/4. It would cross because my multiplicity is odd. Did it have the end behavior of starting high and ending low? Okay. Notice once again, if all of a sudden it doesn't, maybe you started high and ended high. You're like, fricker, frackery, fricker. Gotta find out what's up, right? No. Because what if it was just a regular x cubed? I mean, x to the 9th. We'd look like here. We'd start low. So we'd come here, bounce, bounce. Come up. With me? Shirley? Okay, so the end behavior actually dictates everything. Either A, you started with the wrong end behavior, first off, right? Or you bounced when you should have crossed, or you crossed when you should have bounced. That's really what it is. Okay, well watch, I see what you're saying. Let me show you something else. Okay, not necessarily, what if okay, so I had 0, I had a third, and I had 3/4. Just to make it a little bit bigger. So I started off correct. Where did I mess up at? It's not necessarily him. I didn't mess up on him, did I? I crossed when I should have crossed. I bounced when I should have bounced. I crossed when I should have bounced. Does that make sense? So any of the times, if I'd messed up here, so if I even bounced, right? Yeah. I messed up inside. So not necessarily the guy on the outside. Anywhere you mess up is going to give you a wrong one. Now, if you mess up enough, you might get the right one. You know what I mean? But does that make sense what I'm saying? But at the same time, it's not necessarily those are dictating my end behavior. My end behavior is going to come because that's what is that we can see via our graph. Okay? Yes, no, maybe so? We've spent a little bit, I didn't get to many examples, but I think you guys are getting the concept though, right? The key thing is, are we understanding the concept of what's happening? Okay, in this, they're gonna ask you for sometimes these high points and these low points. What do we call them? This is a relative max and a relative min. Why would this be considered a relative min? Well, if it was on this graph, it's because, well, actually, this is the low of the lows, whatever it is, right? But if I was in an x cubic, or that's 1, 2, 3, 4, so that's x to the 5th at least, okay? Notice, is this the highest I'll ever be? Is this the lowest I'll ever be? Hence why they're called relative mins and maxes. Does that make sense to everybody? Okay. So do you mind grabbing 1-3 out and start handing them out for me in that cupboard right there? Yeah. There's some things that you're going to have to factor. How do we factor something that is 4 terms when it's an x cubed? The only way I know how to do so is factor by grouping, right? We're going to group the first two. What do the first two have in common? I'm left with 4x minus 5. What do the back guys have in common? -3, right? And then notice I have, thank you by the way. What are my zeros? Well, plus or minus square root of 3, right? Because I set him equal to 0 to figure it out. So, really quickly, these guys have their very own zeros, don't they? That's x minus root 3, x plus root 3, and 4x minus 5. Does that make sense? Just because he was an x squared doesn't mean he has multiplicity of 2 there, right? Meaning there's still 2 zeros, and I found them. Right? What's the multiplicity on this guy? 1. What's the multiplicity on this guy? 1. What's the multiplicity on this guy? 1. So at every single one of those guys, there's going to bounce across. Bounce. And we already knew what our leading coefficient was because we already had it in polynomial form, didn't we? That's nice when it's already in polynomial form. We can already see our degree and end behavior, right? Did we end up with the number of zeros we were required to have with an x cubed? How many zeros should I have with an x cubed? Did I have that many? The zeros are square root of 3, negative square root of 3, and add 5 divided by 4, 5/4, right? So I have those 3. I'm going to quickly graph it. I believe it's 1.7-ish. I know it's less than 2, but greater than 1. 5/4 is right here, somewhere right here. Once again, it was x cubed with a leading coefficient of 4, right? Should be like this, correct? But I will be crossing every time. Did I end up with my end behavior? Okay? You guys are doing odds, by the way. Odds.
Like all the odd answers?
Yep, just do odds. Okay, I apologize, but I still think these are good to practice with, but then you can have some extras if you need more. Hey guys, I appreciate it. Hope you have a great long weekend. See you on Tuesday.